Hello everyone, welcome to this webinar on Southwest drought conditions and resources. My name is Joel Lisenby and I'm the Regional Drought Information Coordinator for the Intermountain West and Southern Plains regions at the National Integrated Drought Information System, or NIDIS. If you happen to be unfamiliar with NIDIS, you can learn more about it at drought.gov. For those of you who are familiar with NIDIS, and even those who are familiar with this webinar series and you've come to previous sessions we've held, we usually try to keep these briefings to about half an hour. However, today's briefing will focus on the state of snowpack across the Southwest and the expectations for spring. And as such, we found it necessary to expand today's program just a little bit. We plan to take the full hour. These briefings began during the 2020 Southwest drought as part of the Southwest Drought Learning Network's drought monitoring and reporting team. We plan to continue these as long as the area is in extreme or exceptional drought conditions in the Southwest United States. I'd also like to acknowledge Emily Elias, the director of the USDA Southwest Climate Hub, as a co-lead on the Drought Learning Network team that helps put these together, and also a primary co-organizer on these webinars. We're going to be hearing a bit more from Emily later on. The Drought Learning Network links climate service providers with resource managers and resource managers with one another to increase landscape and community resilience in current and future drought. And this seems like a really good time to plug the annual Southwest Drought Learning Network meeting, which we're planning. It's currently scheduled to be held in person in Las Cruces, New Mexico on June 7th and 8th. There will be more information to come about this. We haven't sent out any emails, so watch your email. You may get some information about this. But if you're interested and you'd like to join the Drought Learning Network and join the annual meeting, feel free to reach out to me or Emily, and we'll make sure that you get the registration email when it comes out. Before we get into the content for today's briefing, I would like to acknowledge that the land that each of us is on today is the ancestral land of tribal and indigenous cultures, and I pay my respect to their elders and chiefs, both past and present, and I welcome all tribal and indigenous people who are joining this webinar today. Also, in terms of some webinar logistics, during this webinar, everyone is muted. The webinar is being recorded. The recordings will be available from the NIDIS YouTube channel and at drought.gov/webinars. The format of today's webinar will be a presentation by each of our 3 invited experts, followed by a time for questions at the end. If you would like to ask a question, you can do so at any time by typing your question into the questions box. And following the 3 presentations, the questions will be moderated by Emily Elias. Now, I am quite honored to be able to introduce our 3 presenters for today. First, we'll hear from Dave Simmerl. Dave is an associate research climatologist at the Desert Research Institute and Western Regional Climate Center in Reno, Nevada. He's been an author for the U.S. Drought Monitor since 2012. Following Dave, we'll hear from Jordan Clayton. Jordan is a hydrologist with the NRCS Snow Survey Program. He's been there since 2012 and has been the supervisor and data collection officer since June 2019. Jordan loves working on the various aspects of Snow Survey's mission, particularly providing expertise in SNOTEL, snow science, and watershed hydrology, data quality control, outreach with water and natural resource managers and the media, report generation and field maintenance. He previously held a position as an assistant professor in the Department of Geosciences at Georgia State University and a postdoctoral appointment with the USGS in Boulder. His PhD is from the University of Colorado and his master's work was at the University of Wisconsin. He grew up in the Chicago area and lived in Wisconsin, Colorado, and Georgia before moving to Utah. Following Jordan's presentation, we will hear from Paul Miller. Paul is the Service Coordination Hydrologist for the Colorado Basin River Forecast Center, where he's been for just over 9 years. As the Service Coordination Hydrologist, Paul's primary focus is in the office is working and coordinating with stakeholders within the Colorado River and Great Basins to make sure that the CBRFC's products and services best meet their needs. So that is my introduction of all of our presenters. I'm going to pass the presenting permissions over to Dave Simmerl to get us started. So Dave, I'm making you the presenter now, and you should be able to share your screen. It looks like, yep, we're seeing your presentation now. It still is in the PowerPoint view. And now we're seeing your presenter view. And now we're seeing the audience view. So you are good to go.
Okay, thank you, Joel. Can you hear me?
Yes, sir. We can hear you loud and clear.
All right, I'll get started here. So quick presentation outline. I'll be talking about the current drought status. I'm going to have a slide on historical La Nina temperature and precip patterns. Then I'm going to dive into a number of the drought and climate indicators. Have a slide with a few of the climate extremes and rankings, and then talk a little bit about drought impacts, and then close with the outlooks and forecasts. So looking at the current conditions, drought status, Western US, as you can see on the right is the current map from US Drought Monitor. And those of you who don't know, the warmer colors are the more intense drought, lighter colors represent less intense drought, white areas are no drought. So we've got about 90% of the West currently in drought. You can see the breakdowns for the states covered in this presentation. Most of the states are of a high level percentage of drought. Taking a look at the bottom left, this is where we were at the beginning of the water year. And you can see we had quite a bit of extreme and exceptional drought, especially in areas of Nevada as well as Utah. Moving to the right, this is the January 4th map, and I put some pluses and minuses on there. And those were, the pluses are areas we saw improvement, and minuses where we saw degradation. And I wanted to show this just to show what kind of change we saw in relation to some of the early season storms that we have, which had a major impact in improving things. Those were mainly in October and December, and I'll talk a little more about that as we go. And then just taking note on the bottom right is a change map. So this is a comparison as to where we were a month ago at the beginning of March, and you can see we've seen some improvement in areas of Colorado, but mainly degradation in New Mexico. Just a little contextual information as to why we've seen some precipitation shortfalls across the region. This is mainly due to a pretty typical La Nina pattern that most of you are familiar with, but just wanted to show you a couple slides from CPC. And this is looking at historical La Nina events for January, February, and March. And on the left, you have temperature, and on the right, you have precipitation. And basically what you get during these La Nina events is we get high pressure that kind of parks over the western areas of the western US, and the storm tracks tend to be diverted northward. And you can see that on the bottom left, that's a 500 millibar geopotential height anomaly. And this is looking at a period for the last couple of weeks in March. And then on the bottom right under precip, this is the typical pattern that you see during La Nina events with areas, generally the Southwest tends to be drier during La Nina, although Colorado is kind of on that margin where it can go kind of either direction. So, whoops, screen is frozen. Oh, there we go. And this is we're moving on to some of the indicators. These are temperature departures. On the top are average temperature departures. So this is looking from left to right, 30-day, 60-day, 90-day. In general, what you can see is below normal temperatures across most of the region, except in the last 30 days, we've seen some warmer temperatures in the western portion of the region in Nevada. Looking at the bottom at minimum temperatures, I thought I would show this. With La Nina patterns, we tend to have more high pressure over the western United States, particularly the southern portions, and we have a lot of temperature aversions that can form, and in the valley areas we tend to get colder than normal temperatures during the evenings, and you can see those across the bottom, lots of pretty cold temperatures, departures. So looking at precipitation on the top, upper left, this is for the water year. I've identified in a couple boxes here some of the kind of standouts for the water year. You can see in western Nevada, as well as western portions of Utah and northwestern Colorado, and some areas in northeastern Arizona, all have above average precipitation for the water year. This is mainly due to storms that occurred prior to January 1st. And then these other boxes are some areas where you can see conditions have been very dry for the water year. And again, most of the precipitation that occurred, especially in northern portions of the region, was due to a couple big storm events during October. And you can see the northern portion of the region well above normal. We had some record precipitation during October. And you can see too, in December, most of the Southwest region was above normal precipitation. Unfortunately, eastern portions of both New Mexico and Colorado were both kind of shadowed from that precipitation. On the bottom, we're looking at 90, 60, and 30 days, the last 30 days. And you can see this drying trend that started in January. Fortunately, during the latter part in the last 30 days, we've seen some precipitation events that impacted areas of especially eastern Colorado, as well as areas of central and south central New Mexico and Arizona. We've got about 2 or 3 storms that passed through those states and those areas during the past month. Taking a look at snowpack conditions, which Jordan's going to get into more detail in the next presentation, but I thought it was important to give an overview of what's going on in the region. As you can see, the warmer colors are representing below normal SWE, and this is as of April 1st, which is an important day when, generally speaking, the snowpack is at its maximum, although for areas to the south and to the west, this date where it hits its maximum is going back a couple weeks in recent years. So we're seeing the snowpacks at their maximum at an earlier date. But as you can see, in my neck of the woods, I'm in Reno, looking at like the Truckee Basin is only about half of normal. Areas, all the basins across Nevada and northern Utah in the Wasatch Front and western portions of Utah, all well below normal. Colorado has had a little bit of a comeback in recent months and has had some pretty decent precipitation to boost up those numbers. As well as you can see in the Southwest, you've got some pretty decent numbers, but this is as of April 1st, and they're dropping off rather quickly. And this is mainly in relation to, there's been 2 or 3 storms that have impacted the basins in areas of New Mexico, as well as Arizona. So each, I've got some time series graphs of charts of SWE, and I just wanted to point out these are a couple different basins from each of the states. And on the left, you can see the Truckee Basin. This starts up in the Sierra Nevada and drains into Nevada, into Pyramid Lake. But what I wanted to point out with some of these graphs are, as you can see, just about to the new year, January 1st, is this flat line of SWE. Basically, you can see that in the Truckee Basin, you can see in the Verde Basin, the Weber Basin up in Utah, as well as in Colorado, and not as much of a flat line in New Mexico, but these, we had a real dry streak, as most of you know, that started in January and continued in March. Fortunately, you can see in some of the basins in the northeast part in Utah and in Colorado, as well as in the desert Southwest, we had a couple of storms, and you can see these little spikes starting at March 1st. But overall, you can see the SWE lines. These are mainly some of these hovering in that 50th percentile area. The ones looking at the Truckee, this is getting into the 30th percentile, which is this yellow area on the graph. Taking a look at some of the climate extremes and rankings, if you take a look at the top map, this is the water year-to-date precipitation percentile ranking. So the warmer colors, you're seeing a lot of the yellows and browns. The yellows are in the bottom 33rd percentile. The browns are in the bottom 10th percentile. And then we have some areas that were above normal precip in western Nevada, as well as areas of central Utah, as well as the northwestern part of Colorado. And those, again, are primarily due to early season precipitation that we had. But I'm not going to go through all of these, but just a few of the numbers that stood out. Colorado, Boulder had the 5th wettest January through March period on record with 5.4 inches of precip. Pueblo, 6th wettest January through March. On the other end of the spectrum, really dry conditions, especially in eastern portions and southern portions of New Mexico, with Las Cruces having its 5th driest October through March period, as well as its 4th driest January through March. Looking at soil moisture and evaporative demand, I've highlighted some areas where we've seen some really dry soils on some of the indicators. Looking to the right are two of the most recent EDI. This is evaporative demand, which is, I'm sure many of you have heard a lot in recent news and what's been driving a lot of the dry soils and the lack of runoff that we've been having. Fortunately, with the below normal temperatures we've been experiencing in recent months, you can see evaporative demand, at least in these two time scales, has been generally pretty low, which is a good thing at this time of year. Although you can see with some of the warm temperatures we've been having in Nevada, especially in the northern portion of the state, as well as in areas of eastern New Mexico and northern areas of Utah, you can see some high evaporative demand. One thing I wanted to highlight was just this is a scan site, which is a NRCS makes soil measurements, and I just wanted to point out one. This is a site that's in the Sacramento Mountains in New Mexico, and you can see recently with these storms, we've had a boost in the topsoil moisture. We're getting closer to median, which is the green line that's on there, but dipped down quickly. But as you can see, that number was in the moisture levels were in the bottom 10th percentile throughout most of the winter. So some very dry soils out there. Reservoir storage, lots of red here, below normal reservoir storage across most of the states in the West. You can see some of the numbers. I'm not going to go through all of these, but these are some recent screenshots I grabbed and photos of some of the reservoirs. Blue Mesa is in really poor shape, 29% full. And this is in the Gunnison Basin, which flows into, eventually dumps into the Colorado River Basin, into Colorado River. Hoover Dam, you can see the big bathtub ring around it. Same thing, Lake Powell, and then this is Jordanelle up by kind of Park City, Heber City area. You can see really low levels there as well. Some of the drought impacts we're seeing in the region. This on the right is NDVI, so it's a kind of greenness indicator. And this is looking at the end of March. And I was trying to get some sort of concept or idea of how many fields are being fallowed potentially in central Arizona in response to the Tier 1 cuts that were made on the Colorado River. And this was one of the areas, big ag areas, that was going to take one of the biggest hits as far as cuts. And you can see these red areas, and I can't confirm that these are all fallowed fields, but there's a pretty good chance a lot of these farm fields, and this is Phoenix is on the north end of this, and Tucson would be on the south end. So this is an area that has been really hit hard by those recent cuts. Some other things we're seeing in the region as well in terms of impacts. You can see this is the April wildland fire potential outlook. So we have above normal higher fire potential in across much of the region. Looking at the current forecasts, the outlooks, on the left side we have temperature, on the right precipitation. On the top is looking at April, so we're looking at above normal temperatures across the whole Southwest region for April, as well as for April, May, June on the seasonal outlook. Precipitation-wise, not looking too great. Next month, below normal precipitation is high probability of that occurring, as well as most of the region for April, May, and June. Looking at the drought outlook, the seasonal outlook, drought persistence likely to continue across almost all of the western United States, as well as some areas that are currently in D0 right now. On this map, you can see they're in yellow. Those areas are expected, drought development is likely in those areas, and that's due to the recent the outlooks in the previous slide that I showed you, and as well as the forecasts in the below normal snowpack that we're experiencing in those areas. And my last slide is just giving an update on the current ENSO status. On the top left, this is the daily sea surface temperature anomalies. And as you can see, consistent with La Nina conditions, basically what we're having is below normal SSTs across the east central and eastern tropical Pacific Ocean. And moving forward, La Nina is expected to continue through the northern hemisphere summer of 2022. 53% chance of this occurring in June through August, and potentially transitioning to either La Nina or ENSO neutral after that. And that should be my mistake down there, 2022 instead of 21. And on the bottom right, these are the differing models that are predicting the sea surface temperatures. And as you can see, on the left-hand side is currently where we are. These dotted lines are the thresholds. Above would be getting into kind of El Nino territory, below the -0.5, getting into the La Nina territory. That's where we are currently. Moving into the next, these are different 3-month periods. And we're expecting, most of the models are showing that it's going to go into neutral conditions this summer. But looking forward into the fall, things are still, these models aren't quite that great at predicting that far out. So we'll just keep watching those moving through the summer months. But hopefully we will not go into a third consecutive La Nina pattern, which would be obviously not good for the Southwest overall, but we will take a look. The last time we had 3 consecutive La Ninas was back in, I believe, 1974. through 76. There were 3 winters in a row. And that, or actually 77, I believe. And that is about it. Thank you much. And I will answer some questions at the end of the webinar if anybody has any. Thank you.
Thank you, Dave. Yes, we'll hold all the questions to the end. We're going to move straight into Jordan's presentation. Jordan, I just gave you the permission to present. I'm not sure if you were able to see that and can share your screen.
Yeah, I shared. Are you able to see my screen at this time?
Whoa, I don't see it. Does anybody else see it?
No, but when I try again.
Here, maybe I'm going to remove presenter permissions from you and then give it back and see if that works.
Did it work this time?
There's some people putting into the question chat box saying that they can see it. So it could just be me and Emily.
Yeah, Joel, I can see it.
Okay, so it's probably just me. Oh, I can see it now. So you're good to go. Thanks, Jordan.
Okay, sorry about the delay. My name is Jordan Clayton. I'm with the NRCS Snow Survey. I'm in the Salt Lake City office, and I'll talk a little bit about Western snowpack conditions. And thank you, Dave, for showing some of our maps and graphs already, so that'll make this a little bit easier as well to go through some of that content. I wanted to start by showing west-wide the snow water equivalent in terms of a percent normal, what we're seeing right now. And so I'll talk about SWE. I think everyone in this group is probably already familiar, but just to be sure, that's the water equivalent of the snowpack. And as Dave was already showing, the maps that I'll be using and also the graphics use the same coloring scheme where anything in green is close to normal, and the yellow to orange to red colors are increasingly bad, where we're getting into below normal conditions, and vice versa for blue to dark blue. On this map, you can see the percent normal values for the major basins in the Southwest, and also shown on this map are the individual snow-tell sites where we measure the snowpack, and you can see those are also colored by the same coloring scheme. As was mentioned, we can see below to well below normal conditions for most of the Southwest based on median and the last 30-year period being 1991 to 2020, with a little bit of an exception for northern New Mexico and southern and southeastern Colorado. As you can see, northern California and most of Nevada are also hurting quite a bit from a percent normal perspective. Not all of us are used to median as our measure of central tendency, so I thought that I would also show the same map, but this time for comparison, now we're looking at the whole period of record going back to 1978 for many of these locations. And this is now in terms of a percent of average. So now we've switched from median to average, and we're also looking at, instead of just a 30-year window, going back to the beginning of the snow-tell measurements in the late 1970s. The same information here in terms of the amount of snow water equivalent, but obviously characterized by a different normal. When we do that, we can see, based on the full period of record, that the conditions look actually worse. I do think it's healthy and important to look at the full period to get a sense for how things are comparing right now. Again, you can see Nevada and Northern California in particular, and also, of course, portions of Arizona and New Mexico in the red. From a percentile perspective, these are also, these are again snow-tell sites in the Southwest, showing based on today's snow water equivalent how things rank. You can see the percentile legend in the bottom left. Where it's red, we're in the bottom 15th percentile from a snow water equivalent perspective. And there's quite a bit of red in Utah, southwestern Wyoming, northern Nevada, and the area around Lake Tahoe. Other areas of the Southwest aren't quite hurting as badly as I think Dave was also alluding to in the previous presentation. Southwestern Colorado is certainly got a mixed suite of results, and other portions of Colorado also have seen some areas receive quite a bit of snow and other areas not so much. You can see for most of northern Utah and Nevada, and again the area around Tahoe, the conditions are below normal to the bottom percentiles on the map. Looking at snow depth, you can see also for today the percentiles for how things rank. Obviously, when we don't have a lot of water equivalent in the snowpack, we don't expect the snow depth to be outstanding either. Similar pattern here to what I showed on the previous slide, but some information can be gained from looking at snow depth as a percentile as well. You can see quite a few snowtell sites in the bottom 15th percentile, again, in northern Utah, southwestern Wyoming, northern Nevada, and the area around Lake Tahoe. Well, clearly, when we're looking at snow depth and snow water equivalent, we can resolve snow density, and that's what's shown here. We see a bunch of blue pop out, and the reason why is that we're looking at anomalously high percentile snow densities for this time of year. This is, again, a map for today. This is as of midnight last night. And so you can see across the region, quite a few locations that have high snow density for this time of year. And that's concerning for several reasons. One is, as we probably already are aware, most of the snowtell sites in the state of Utah and beyond have started to melt. In some cases, this is significantly early, particularly our high elevation sites. And the reason why that's possible is that we reached high levels of snow density at an earlier time than normal. So again, these are percentiles showing how these snow densities would rank going back the full period of record. I also thought it'd be interesting to look at how snow densities have changed over the last 30 days. And that's what's shown here. This is the actual value changes for, again, the snowtell sites and how the density has increased over time. That's not particularly surprising. This is a period from March 5th to April 4th, and we would expect snow density to increase during that time. As you can see across the west, when things are starting to warm, day length is getting longer, all those things that make snow density increase. However, if we look at the anomalies, these are areas where the snow density increases over that period are anomalously high. So this is, again, looking at those same snow density increases, but now looking at how they depart from normal. And there's quite a few that are in that greater than 5%, higher than normal when we consider, again, what would be normal snow density increases over that period relative to what we've seen. Quite a few in that dark blue, and then some in the kind of light blue shades as well, showing that they're higher than they would normally be for that 30-day period. Dave already did a nice job covering precipitation. Just generally, if we're looking at broad HUC2 regions, for the upper Colorado, we see we're about 95% of normal. This is, as he mentioned, a time series graph. So we see the current water year shown with the black line. The median conditions are shown in the green line. And I also plotted last year, 2021, for comparison. You can see how abysmal 2021 was, which is that pink line below the black line. And the rainbow coloring in the background, those are the percentiles from the range of observations that we've seen. So again, upper Colorado, a little bit below normal at 95%. If we're in the lower Colorado, we're a little bit worse, about 84%. You can also see last year with the blue line plotted below this current water year in the black line. And then also for the Great Basin, currently about 94% of normal. You can see last year setting some record minimums through portions of last summer for the Great Basin. We did set quite a number of new records for the 50-day period from January 11th to March 1st. As Dave was already talking about, the precipitation really flatlined over really most of this region for that period. And you can see that reflected here with the snowtell sites. These are the rankings for lowest precipitation over that 50-day window. And you can see there were quite a few records and quite a few that were second worst, which would be orange. So everything you see on this map was a record minimum for that 50-day period, and everything in orange was the second worst. So not the kind of records we want to be setting. And then finally, some snowpack projections. We can look at the range of outcomes that we've seen in previous years and develop some projections for what we might see from today forward. And we can do that for the different regions that we already talked about. So for the upper Colorado, if we look at the current water year, which is the black line here for snow water equivalent, we can project forward with the range of possibilities, where the most likely outcome is the middle strand, if you will, of the rainbow spaghetti. And then the max probable is that upper blue line, and the minimum probable is that lower pinkish reddish line. And the most likely outcome is that we're going to be in that 10 to 30% percentile for the upper Colorado, although you can see there's a range of possible outcomes from doing quite well, which is what I'm hoping for, to really bottoming out. Same thing for the lower Colorado, although the projections aren't quite as optimistic there. We're not in as good a shape there. You can see there's quite a bit of snow that's already been lost for the lower Colorado. Here for the snow water equivalent for that region. And then finally for the Great Basin, same thing. You see there's really no projection for the Great Basin that puts us back on track, at least from a max SWE perspective. And similarly, I'm happy to answer questions at the end of the presentation series, and thank you for including our information.
Thank you, Jordan. That was great. And I'm looking forward to some of the Q&A time. We've got quite a few interesting questions coming in. I'm now going to transition to our final speaker, Paul Miller from the Colorado Basin River Forecast Center. So Paul, I'm giving you presenter permissions now, and let me know how you go with that.
Sounds good. Okay, can you all see my screen?
Oh, I can't, but I think I'm just slow. I think so. People are putting into the chat box that they can see it. So go ahead. My computer will probably catch up.
Sounds good.
We
Well,
can
I
see
talked
just
to Joel last week, so hopefully this is a lot of review for him. So just a really quick overview of who we are at the Colorado Basin River Forecast Center, and just some of the latest conditions in the basin and our current forecast, and then some of our future snow-related efforts. I just want to talk about some of the research that we're doing and just scratch the surface on that, really, just to keep people in the loop. So we're one of 13 river forecast centers nationwide. We work with a subset of the 122 weather forecast offices that cover everywhere. So when you're sitting at home and you get the alert on your cell phone that there's a flash flood or a flood, that's coming from one of our weather forecast offices. But we're in the background providing support, how long that flood's going to last, what the peak of that flood could be, anything like the recession, any sort of information that we can do to help our WFO colleagues. So here in the West, because water supply and the reservoirs are so important, we have this additional role of providing water supply services. And I like to think that at the CBRC, we're helping to lead that effort. So at the CBRC, this is a map of our water supply locations. We do forecasts at 174 of these locations. Most of them involve seasonal water supply forecasts. That's when we say seasonal, we're typically talking about that April through July volume. We also make daily stream flow forecasts at about 460 locations. They're mostly 10-day forecasts, but we do have a subset that go out 15 days. And like I said, we work with the WFOs, but really what we do and what my job is focused on is working with our stakeholders to make sure that these forecasts and these locations and these thresholds and the timing of these forecasts and when they're released is helping our stakeholders meet their decision support goals. So for instance, when it comes to the Bureau of Reclamation, there's times during the year where our water supply forecasts make big impacts to what they're planning to do with their reservoirs. So making sure that we have those products in a form and a format that they can use and readily input into their hydrologic models is really what's important to us. So here's just a schematic that I like to show that just shows all the stuff that we do to bring into our model. And we won't get into the details of it, but basically our model is a version of the Sacramento Soil Moisture Accounting model coupled with Snow 17. And we are data consumers. We bring in so much observed data from our partners. We don't typically manage our own gauge networks, but we rely heavily on the USGS, the NRCS like Jordan, our stakeholders that operate reservoirs like Reclamation, and others. That's just, maybe that's just the top 3 providers forecasted operations and weather from our weather forecast offices and reservoir operators. We spend a lot of time calibrating our model. We have modeled soil moisture that we rely heavily on. And then we look at this model every single day. We sit down, we go through all 470 of those locations. We look at all 174 of those water supply points, and we try to make objective, physically based modifications when they're necessary to provide the best forecast that we can. And I like this little funny Lego vignette that we do this even during telework, and we've got our kids jumping around. But this is what we look at every day. So we sit down at the model. This is an example of the Green River up in Wyoming. And here we've got a watershed that's been divided into 3 elevation zones, kind of represented by these 3 top bar and line graphs here. And what that's showing us is our historical temperature and precipitation information on the left of this red line, and what our forecasted temperature and precipitation is on the right of that red line. So you can see here where it looks like we're about to enter, and this is from a few years ago, so it's not a current forecast, but the graphic is nice because there's stuff happening in it. That's really interesting to look at. So here you can see that this plot is showing me that in the upper elevation range of this watershed, we're seeing some warmer temperatures. We're seeing some snow melt represented by those green bars. Historically, our model, represented by that blue line, is comparing very well to observed data from the USGS, represented by these red dots. And so we feel pretty confident that looking out at least the next 10 days, that our forecast is going to perform reasonably well. And you can see, as we see that melt from the higher elevations, you see that hydrograph rise in response to it. So we spend a lot of time with our model making sure that we get as many of those sites behaving as accurately and as well as we possibly can. And that forms the basis of what we call our initial states. So that's our initial model states. From there, we use historical traces of precipitation and temperature from 1991 through 2020. And we forecast out a water year. Typically, we're only reporting out seasonal values or different months, but we run our model out at least a year ahead, and we're cycling through those historical precip and temperature traces from 1991 through 2020 to give a range, or what we call an ensemble of possible hydrologic futures. So we don't do any weighting. Every year we feel like is equally likely. Though all the traces are available to our stakeholders so that they can do any sort of weighting that they might like to do. In the lower Colorado River Basin, we do weight a bit based on some different ENSO indices. So there's a little bit of weighting that goes on in the lower Colorado, basically Arizona forecast sites. But for the most part, that's how we come up with this ensemble of possible hydrologic futures that forms the basis of our water supply forecast. So just kind of going into what we're seeing this year, we're seeing our model looks at really deep soil moisture conditions, and there's not a gauge network that's out there that's really dense enough and spatially distributed enough that is measuring these soil moisture parameters that our model is trying to capture. So for us, we infer this information through calibration, looking at base flow conditions in the fall after the snow has finished melting and after irrigation season has ended. And we can kind of come up with a good representation of what soil moisture conditions look like. And this fall, there was just very dry conditions throughout the basin. I think they marginally improved from the previous year, which was just very, very dry. And based off of these initial soil moisture conditions, we expected an inefficient runoff this year, just because we were seeing that the snow was going to need to replenish some of these dry soil moisture areas before we could really get runoff going. And we recently did a model sensitivity analysis that showed for every 5.5% decrease, sorry, let me back up. We recently did a sensitivity analysis that showed for every 1% decrease in soil moisture from average, it resulted in about a 0.5% decrease in annual runoff, just in general. This year we started the year off wet. We got off to a really great start. There was above normal snowpack in most areas. And most of our forecasts were near to slightly above normal, even despite those dry soil moisture conditions. But I think like Dave and Jordan just showed, we had a historically dry February, which really brought a lot of our forecasts down. Again, kind of hitting on our water supply forecast and what their current state is, most of these forecasts are in that 60 to 70% of normal range. And these dry conditions, and I should stress the persistently dry conditions, have really been the primary driver for these reduced inflows. So this is hot off the presses. Our official April forecast just came out like a half hour ago, so I was updating the slide just after we got started here so that I could show it to you. But this is what our official forecast is showing. You can see here over to the left in January, our initial forecast, the median value, you can see with the 50% exceedance probability here, was very close to average and median values for inflow going into Lake Powell. And that was just a result of, one, above average snowpack conditions for the most part throughout the upper Colorado Basin, and also accounting for those dry soil moisture conditions. I think if we had just factored in snowpack, the forecast would have even been higher. And then you can just see what the results of, things started dry in January, and when February came around, just a really, really dry February. We didn't see much precipitation until the last part of the month when things improved just a little bit. But now here in April, we're looking at about 4.1 million acre feet forecasted into Lake Powell, which is just about 64% of average. But there's a lot of, you can kind of see here, this blue shaded area is that range of ensembles that I was describing how we develop each year. So we're saying, there's a chance we could get back up to normal conditions, but we're thinking it's not likely at this point going forward. I also want to talk about, in our office, we recently have come very close to completing our normals update, where we update to the latest 30-year period. This is mostly because we want to conform to the World Meteorological Organization standards. So that's why we focus in on that 1991 through 2020 period. We also want to acknowledge recent trends in the data. We know that our basin is warming. We know that precipitation trends have started to change. And it's an opportunity for us to thoroughly evaluate our model, make any changes. We're making changes all the time, but this is just a really good time where we can go through all our data, all our segments, and just make sure that we're modeling things to the best of our ability. And just to show how things have changed since our last 30-year update, our previous 30-year update was this 1981 through 2010 period. And you could see that our April through July volume was about 7.1 million acre feet on average. And since switching over to the 1991 through 2020 period, it's just a little bit below 6.4 million acre feet on average. And you can kind of see a similar decrease on the water year side of things as well. So overall, about an 11% decrease in the unregulated averages, just shifting to that 30-year period of record. This graphic just kind of shows the same thing, and just showing how the streamflow variability in the basin has trended downward, and how that mean has trended down. And it also draws to the last 5 years have been really, really dry, just under 9 million acre feet of average unregulated flow into Lake Powell there. So just very dry. And just to chat a little bit about our research efforts going on with Snowpack. Currently, when it comes to Snowpack, we rely heavily on our calibrated model and gauge information. But we're working with folks like the Airborne Snow Observatory to see if we can use that information to estimate snow water equivalent in our model. So Patrick Cormus in our office has done a ton of work where he's been able to take some of this data from ASO and directly inject it into our model. And what I want to show first is this is our forecast from last year. This is the Blue River near the Dillon Reservoir. And you can kind of see how our forecast evolved, and this plot that we've come up with. This is exactly the same thing I showed for Lake Powell a few slides ago, but just what the finished product looks like after we've gone through the April through July runoff period. So you can see how the forecast evolved and how the data observed. So just kind of keep this plot in the back of your head as we look at this plot. So this is a plot that Patrick has come up with. And I just want to stress that this is 2 flights at 1 location for 1 year. We can't come up with definitive answers yet regarding using ASO data. Also, our model has not been calibrated to use ASO data. So this is mostly like a proof of concept. But I really like that Patrick's been able to come up with these graphics that look like our current evolution plots. And you can see here, these are the 2 flights that ASO made in 2021 that we could use at the Blue River near Dillon. And you can kind of see what the forecast would have been had we just taken that data and directly inserted it into our model. And I don't think it's fair to say whether this improved or worsened our forecast at this point, because again, it's just 2 data points at 1 location with a model that hasn't been calibrated using this data. So I just wanted to show that we're just making a lot of really great progress investigating this data and looking forward towards hopefully using it more in the future. Oops. Oh, sorry, some little annotation on the graphics there. So there's lots more that we're doing. We're working with a group called the Colorado River Climate and Hydrology Work Group that's loosely led by the Southern Nevada Water Authority, and there's lots of snowpack research going on. We've recently partnered with Reclamation and the NRCS on a funded project that's going to look at the impact of the Snowtel network and optimal placement of future Snowtel stations, which I'm really excited about. We're partnering with several universities and researchers to investigate even more improvement pathways. We're working with folks at the University of Colorado, like Noah Malich, and the University of Arizona, like Patrick Broxton, with these different snow products and data that's starting to come out. And like I mentioned, we're working with the Bureau of Reclamation and a lot of these other agencies through the work group to fund these research efforts, which I think has been really great. And again, just really feel free to reach out. And if you have any questions or comments, literally my whole job is working with stakeholders, working with our partners to make sure that we're meeting your needs. So I'd really love to hear from any of you. Any comments or suggestions you have, I think that'd be great. So hopefully I stayed within time, Joel, and I'll turn it back over to you.
You did fine. Thanks, Paul. Oh, sorry. I'm going to pass over to Emily to do the questions. Thanks, Emily.
Great. Thanks, Joel, and thank you so much, Paul Miller, Jordan Clayton, and also Dave Simmerl for sharing your knowledge and sharing this information with us. We have time for a few questions. I'm going to start with Paul, a question for Paul related to the most recent presentation. And the question is, recent news accounts have mentioned the possibility of Lake Powell dropping so low that hydropower operations wouldn't be possible. So how could the current forecast of 64% of average inflow into Lake Powell affect that? Do you have any ideas about that current forecast and the effects on hydropower or any other effects?
Sure, that's a great question. And like I mentioned earlier, Reclamation is probably probably our key stakeholder in the basin. They rely heavily on our forecasts, and our forecasts drive what their reservoir operations model, which is called the 24-month study model. And they base their decisions really heavily based off of our forecasts. So what I would say is that I'm going to defer a little bit to reclamation, and I'm also going to defer a little bit into the future. In about 2 weeks, reclamation is going to use this forecast that we've just published, and they'll issue their latest 24-month study, and it's going to show the projected operations and future storage conditions at Lake Powell, and you'll be able to see how close that they're getting to those power pool levels. But what I will say is that a lot of our stakeholders that rely on Powell for water supply and hydropower, they've been working very closely together and collaboratively to ensure that has a low likelihood of happening. But we can definitely get you in touch with our reclamation partners if you want a more detailed answer regarding what they're doing and their different policies and stuff regarding Powell's power pool.
Perfect. Yeah, thank you. That's great. And my next question is for Jordan. And this relates to what you showed around the high snow density or higher than average or normal snow density. And so the question is, do you have thoughts about why we reached that high snow density earlier than normal? And there's a follow-on to that question about whether or not it could be pointing to or fingerprint of climate change.
Yeah, that's a nice question, and I think that's clearly something that we could link to, or at least it's consistent with what the models have shown is going to be an impact of global warming. And so I think that's completely reasonable to make that connection. One of the things that we're seeing that's causing the densities to increase is we're seeing, in addition to the obvious factor, which would just be warmer temperatures, we're seeing sometimes the new snow that's coming in has tended to have a higher density to begin with. So we're still getting that real light powdery snow, 5 to 8% density snow when it's falling sometimes, but not all the time. And sometimes the snowpack, the snow that's being received is actually coming in at a little bit higher density. There's been a little bit more liquid water content mixed in with snow in a lot of these storms, even at higher elevations. And we've also seen a trend for even at the high elevation sites for ripening, where the snowpack is ready to melt at an earlier date than we had previously seen, and then getting significant snow after the ripening date. So what that means is once the snowpack is ready to melt, when you add more snow on top of it, it's going to take less energy input into that snowpack to bring it again to that melt phase, compared to if you were waiting until a little bit later in the season when you would normally see that ripening phase. So it's a combination of factors, and certainly warmer temperatures are on that list.
Excellent. Thanks, Jordan. And my last question is for our first presenter. So Dave, this is a question for you, and it's really a question about a recap of the expectations for ENSO. So we're in La Nina, and where do you expect that to go moving forward?
Yeah, thanks. Yeah, as of the latest IRI CPC model predictions for March, the April one will come out pretty soon. But right now, again, we're in La Nina conditions now, but looking at a couple different things, looking at the CPC consolidated, as well as the average of the dynamical models. Most of them are looking like we're going to transition into ENSO neutral during the summer months. And it's also looking like most of the models are also showing that we're going to continue with that ENSO neutral into the fall of 2022. But we're still kind of far out. And I think for looking at the fall and how reliable those model projections are. So I would say we'll keep looking in summer months to see which direction, if it's going to go neutral or back to La Nina again. But I think there was a question that if we would go into El Nino, and no, there's basically only one of the models is showing potentially moving into El Nino. So I would say that's low to no probability of that occurring.
Okay, great. Thank you. Thank you all so much for joining us on our Southwest Drought briefing. Thanks to Dave Simmerl with Desert Research Institute, Jordan Clayton with the Utah Snow Survey, and Paul Miller with NOAA's Colorado Basin River Forecast Center. It's really helpful for you to provide this information for us, and also thanks to my co-host, Joel Lisenby. Our next webinar will focus on wildfire. It will be June 2nd, 1 p.m. Mountain Time. We'll also have our in-person Drought Learning Network meeting that's open to all June 7th and 8th in Las Cruces, New Mexico. Please reach out if you're interested. This will be hosted on drought.gov/webinars. So if you missed part of it, you can catch it in a few days on drought.gov. And with that, thanks again for joining. This concludes our webinar.